So I lead the oil and gas practice for ZEDEDA, and I'm joined here today by two industry veterans in the energy space as well as industrial IoT. Sashi Gunturu is joining us from Petrobytes, and Tom Arthur is joining us as CEO of Dynamics. And I'd like just real quick to have each one of you, start with you, Sasha, introduce yourself and tell us a little bit what Petrobytes is about.
Yeah, so we are a Houston-based data analytics company providing energy solutions primarily for upstream, both drilling and production, and also for the pipeline industry. Again, our team has over 20 years of experience developing enterprise software for the energy industry.
Great, thank you, Sasha.
And my name's Tom Arthur. I'm a co-founder and CEO of Dynamic. Dynamic is a contributor to Project Fledge, which is the Linux Foundation's industrial IoT platform. We have now about 70 other contributors to the project. So other major contributors include companies like Google, OSIsoft, and industrial companies like RTE, which is one of the largest TSOs. That's an energy company in the EU, and Oleander and Koch Industries. And we then also offer commercial support for Fledge, which we call Foglamp.
That's great. I mean, you can see that quite a bit of experience here and really around the reference architectures, edge reference architectures for the energy space. Sasha, starting with you, kind of what, talking about OSDU, what's been the mission around that and how have you been involved with that community?
Yeah, as you know, energy companies are collecting lots of data in several terabyte scale. They have different systems and they have lots of vendors. And especially the subsurface data is extremely complex with 3D and time series data and unstructured data. So, and there have been a lot of standards being developed, but then the exchange of the data has become a big problem. So now the major energy companies combined with tech providers have formed what is called the open subsurface data universe. And the goal here is to provide a interoperability standard. That way there is a common data model and the way you exchange data between systems and softwares and vendors is completely standardized. Just like how you had HL7 for the Medicare, for the healthcare industry with electronic health records. So everybody's exchanging data in a standardized way. So that is the goal with OSDU. So at Petrobytes, we have been working, one of the software that we have is on fiber optic sensing, where we are collecting lots of data and analyzing that information both for distributed temperature sensing and acoustic sensing. And the data becomes significantly huge, so we developed our own architecture to process the data. So what we needed is an intelligent edge, and the reason why we got involved with OSDU is to provide that intelligent edge reference architecture rather than just collect and transmit information, right? So that's how we got involved with the reference architecture.
Got it. How long have you been involved?
The project has been going on for like about 8 months now. Again, we are constantly evolving in that space in developing the standard.
Got it. Thank you, Sashi. So Tom, how did you talk a little bit about your edge, how the edge POC came about for you guys? Conclude like your entire stack and the initial effort.
Sure. A little background on the company. So for those that are familiar with a company called OSIsoft, which was bought recently by Aviva, OSIsoft builds a product called Pi, which is a data historian, and it's predominant around process manufacturing. So one of their first and biggest customers was Shell Oil, but probably in about 70% of oil and gas, you'll find the Pi historian. You'll find it in energy. Probably 80% of the energy companies in North America use the Pi. And so working with OSIsoft, what's happening today is exactly what Sashi talked about, is there's more and more data, more and more processing, think machine learning, not connected to SCADA. And so that data is not finding its way to the historian. So we started a project with Google and OSIsoft to build an open source stack that would do industrial IoT to collect, transform, and integrate the data to all the various destinations you'll find in the OT world. And so I call that intelligent OT data pipelines. And that's how we got started. And with that, we met the CTO of Shell Oil, a gentleman, Johan Krebers, who's also one of the co-founders of OSDU. And that's how the ball got rolling.
He's been very involved, and you guys have been very involved as well. So Shashi, what are the next steps that you see in the POC with OSDU?
Yeah, so we tested the Fledge and EVE stack, and then we did the drilling POC. Now we are looking at the production forecasting pilot project. So the goal is to take some of the public data sets and also try to build that intelligence capability, right? So the idea of the intelligent edge is the reference architecture is to provide not only just transmission, but also can you store the data, can you compute, can you provide analytics at the edge? So that is the goal of the next production POC. And then we are also looking at other areas in terms of pipelines and things like that, because the OSDU right now is looking at the subsurface, but it will eventually evolve into all of the energy sector. So,
all of it.
And also Chevron is setting up a edge lab. So that is the next thing that will be helpful for the community, where you can now test the edge devices with their lab in Houston.
Yeah, that's got to be important. There's been a big need for that for some time now. So Tom, could you share with us about the use cases that you're seeing in the energy space, utility space?
Sure. Let me kind of divide what I'll call the pipeline into three main values. Yep. So the traditional one, starting in I'd say 1995 with companies like Kepware, was I'll call it the multi-protocol gateway. How do I take the many protocols you'll find in oil and gas or any industrial, convert that to some common protocol and get it to where it needs to go. And then the second thing that started getting done is then data transformations. So when you start looking at many of these ISA 95 systems, most of them written in Windows, they'll have an existing schema or data format expectation, which will be different from the sources. So then doing data transformations, so you can match schemas and do various data manipulations to make the end-to-end work. And then the third workload is exactly where Sashi's talking about, and that is smarter and smarter edge applications. Ultimately being things like machine learning, where inference runs on the edge, which is all about managing the pipelines that feed inference, the abilities to move machine models out to the edge, manage the life cycle of those models, and so forth. So a use case in oil and gas that is one of our larger ones is one of the major pipeline companies in North America. About 30% of their pipeline is in very remote areas with no power. And so you end up with a power problem as well as a networking problem. So how do you mount sensors out in a non-SCADA world that are measuring flow rates, pressures, temperature senses on these pipelines? How do you, when the network's only available 10 minutes a day, how do you do updates and deletes down to the application? How do you set alerts? How do you pull updates down? How do you send alerts when the network's not available and turn the network on? So we've been, one of the bigger deployments we have in oil and gas is exactly that, covering 30% of the pipeline not covered by SCADA remotely.
Yeah. I bet the payback on that and the benefit to the customers is intense. That's big.
Yep, they're fun projects too.
Sashi, how about you? What are you seeing as far as use cases and maybe something you can share?
Yeah, definitely. As Tom mentioned, pipelines. Just US alone has 2.5 million miles of natural gas pipelines. Even within pipelines, there is not just there is SCADA systems and there is also terminals. So there is a lot of opportunity for edge computing. I think even in the upstream sector, we see opportunities more on the production use cases, apart from once we prove out this first aspect. And as companies are moving towards energy transition, you would see use cases on, wind, like looking at turbine, wherever there is no access to high scale compute, the edge will come into play. So, especially remote monitoring applications.
Yeah. And as Tom said, in fact, with the challenge you have with the remote connectivity and connectivity being intermittent, being able to do that on-prem is important to do real-time analytics.
Yeah.
So help us understand from energy companies, what would it take for them to get involved with OSDU and how they can participate?
Yeah. The good thing is all the major cloud providers are providing instances, like AWS has one instance, like test instance, and the energy companies like Equinor has donated data. So you have test data, test environments being created now, both for the cloud instance, like the DDMS for the cloud, and also for the edge. So I think as companies, I mean, they're now looking at what can you do. Now they've built a standard for basically the input IO into the OSDU instance. Now, what else can you do? Can you provide insights from there? So that is the next evolution of OSDU, where companies can now consume the data and provide more insights. And the standard will continue to grow because there are a lot of data sets that they still need to address, like seismic.
Sorry about that.
Yeah, I think more companies will get involved in this, and I think the next evolution will be on what insights you can derive once you have the standardized interface.
Mm-hmm. Tom, what are your thoughts as far as energy companies and putting a toe in the water here?
Yeah, what we're running into in energy companies is also the vastness of the data type, and so what you find mostly 80-70% is time series data, but more and more vibration data. So you kind of mentioned it on the remote stuff. When you have latency issues, networking issues, those are challenges. But when you start managing vibration data and video data through the same processes, the amount of data is overwhelming. And so when you start looking at machine learning applications in this space, you'll often have not just a PLC connected to some pump or piece of equipment. You'll have accelerometers running at 10 kilohertz and maybe multiples of them. And so some of the applications being built today are pretty involved. And pretty large data sets. They have to be processed on the edge because of the latency and the amount of data, but even the types of data and combining those and then integrating all that to really this new terminology in ML called ML ops. So you have some nuance in machine learning when you actually do inference on the edge and you do data collection on the edge and you have the different data types on the edge. And you certainly find these kinds of use cases all over energy.
Yeah. Well, gentlemen, I appreciate it. You know, what you bring home and what you take is the fact that for open source, there are solutions that are in play and there's a support model that's in play for that. And what I've seen in the energy space is kind of analysis paralysis. They like the open source, like the idea of having an environment where they can test and play and develop, but they don't know where to start. And I think what Dynamics and what Petrobike shows is that it's a crawl, walk, run, just getting started, getting involved with OSDU and beginning to test around, play with some of these things is what, as you talked about with your use cases, or what examples that people have been to take into production.
Yeah, I think the Chevron lab will also help because people can actually see all these things happening. So,
yeah, it's a great point. So we're about out of time. Tom, I'll start with any lasting comments, any takeaways?
No, it's just IoT and the edge compute and open source tools are starting to make a difference in this space, and they are ready for prime time. They are getting deployed and ready to use, and groups like OSDU are helping promote them and put them out there.
Thank you. Sasha, any last words?
Yeah, I mean, oil industry has been typically client-server solutions for a long time, and then the cloud has taken over now. So now, next thing is the edge. Next big thing that is going to make a big impact in oil field is the edge.
Great. Tom, Sasha, thank you so much for your time today. I appreciate it.